Hello students, let us continue with the next topic under the teaching content program in our college. So in today's class, we are going to study regarding rotational spectroscopy under molecular spectroscopy. So today's topic is going to be rotational spectroscopy under molecular spectroscopy. Coming to rotational spectroscopy, microwave region is concerned with the rotation of molecules. Microwave region is concerned with rotation of molecules. A body has three principal moments of inertia, one about each axis, usually designated as IA, IB and IC. A body has three principal moments of inertia about each axis, usually designated as IA, IB and IC. Molecules may be classified based on their principal moment of inertia. Molecules may be classified based on their principal moment of inertia. Coming to the classification of molecules based on their principal moment of inertia, we are having four types of molecules. They are linear molecules, symmetric top molecules, spherical top molecules and asymmetric tops. So these are the four types in which we can classify molecules based on moment of inertia. First, coming to linear molecules, atoms. In linear molecules, atoms are arranged in a straight line. In linear molecules, atoms are arranged in a straight line. Hydrogen chloride, carbon oxysulfide, carbon oxysulfide. The three directions of rotation may be taken as about the bond axis, end over end rotation in the plane of paper, end over end rotation in the plane of paper and end over end rotation at right angles to the plane. So we are having three directions of rotation which are about the bond axis, one about the bond axis, another one is end over end rotation in the plane of paper and end over end rotation at the right angles to the plane. For a linear molecule, IB is equal to IC and IA is equal to 0. For a linear molecule, IB is equal to IC and IA is equal to 0. In case of symmetric top molecules, coming to the next type, symmetric top molecules. Symmetric top molecules have equal principal moment of inertia and the third one is unique. In symmetric top molecules, two have equal moments of inertia and third is unique. That is, IB is equal to IC and the third one is going to be different. They are not same. That is, IA is not equal to 0. They are further subdivided into two categories. Symmetric top molecules are further divided into two categories. One is prolate symmetric top. Example under that is methyl iodide. This is going to be methyl iodide when one hydrogen. If this is going to be methane, if this would have been H, then it would have been methane, but it is replaced by iodine. So this is methyl iodide. This is prolate symmetric top. And I have got oblate symmetric top molecules. Example is going to be BF3. Example is going to be BF3. In prolate symmetric top molecules, here IB is equal to IC. Here IB is equal to IC, but IC is going to be greater than IA. That is, IB is equal to IC and that is going to be greater than moment of inertia of A. This is prolate symmetric top because one is going to be IB is equal to IC and IC is going to be greater than IA. In oblate symmetric top molecules, example is going to be BF3. Here IB is equal to IC, but this is less than IA. It is going to be less than IA. When IB is equal to IC, it is going to be greater than IA. It is prolate symmetric. But if it is going to be IB is equal to IC and it is less than IA, it will be called as oblate symmetric top molecules. Next is spherical tops. In spherical tops, all the three moments of inertia are identical. In spherical top, all the moments of inertia are identical. Example is methane. Example is methane. Where under the axis, that is IB is equal to IC is equal to IA. In spherical top, all the three moments of inertia are identical. Here IB is equal to IC is equal to IA. They have no dipole moment owing to their symmetry. They do not have any dipole moment owing to their symmetry. Rotation alone can produce no dipole moment. Only due to rotation we cannot produce dipole moment. Hence, rotation spectrum is not observed in case of spherical tops molecules. So, in spherical top molecules, no rotation spectrum is observed as they do not have dipole moment. And the last one is going to be asymmetric top. In asymmetric tops, all moment of inertia are different. In asymmetric tops, all moment of inertia are different. Example is water and vinyl chloride. In this case, IA is not equal to IB is not equal to IC. Here, IA is not equal to IB is not equal to IC. That is, if we have to just summarize the classification based on moments of inertia, when we have to summarize based on the classification moment based on moment of inertia, I have got spherical top, symmetric top, linear and asymmetric. In spherical top, IA is equal to IB is equal to IC, that is I, and example is going to be methane, carbon tetrachloride, sulfur hexafluoride. And in symmetric top, we have got two types. One is prolate and oblate. In oblate, IB is equal to IC, which is less than IA. Example is going to be benzene. And in prolate, IB is equal to IC, which is going to be greater than IA. And example is going to be methyl iodide. In case of linear, this is a symmetric top. The symmetric top here, IA is equal to 0 and IB is equal to IC. All diatomic molecules and examples, all diatomic molecules and examples like carbon dioxide, nitrous oxide and acetylene comes under linear rotor. And asymmetric top, here the moments of inertia are not equal. Example is water and vinyl chloride. Okay, so with this we complete this class. Thank you.